Welcome viewer to this second session of our second module of this course of machine design. We have discussed in our first module about the design equations, and then we have discussed how the right hand side of this design equation is obtained, that is design stress based on the strength. We discussed about the difference between strength and stress in our first module. Then in the first session of our second module, we were focusing on the left hand side of this equation, and in left hand side we are interested in calculating how much is the induced stress, and induced stress can only be obtained if we know how much load is acting and what is the effect of that load. We have discussed how to calculate load from our force analysis using free body diagram, and now in this session we will be discussing how to identify what is the effect of that load. So let us begin with the effect of load and try to answer this question: what would be the effect of axial load? It means we have this type of member and it is subjected to some axial load. It means the load is acting along the axis of this member. So load can be either this or this. It would be axial deformation, whether it is tensile or whether it is compression or tension. So we have the axial deformation. So when we do not have axial load, then this type of load is called eccentric load. So in such case, what would be the effect of load if the load is not axial? So let us try to analyze this with this particular situation when we have this cantilever beam and a load F is acting, and we are interested in finding out the effect of load at point B. So for point B, this load F is eccentric. If we want to find out the effect of this load along this line of action of force, then it is not the eccentric load. So in these cases we have to transfer the load from position C, from point C to point B, and whatever system of force we obtain at point B, that will basically fix the effect of load at point B. So it means it should be clear whenever we are designing any component, a load is acting at some remote place, and we are interested in finding out the effect of that load at some point of interest where we feel that here the stresses will be maximum. So what we have to do first, we have to replace or transfer that load from the point of application to the point of interest. So we have to shift this load F from this point C to this point B, and whatever will be the system of force that we obtain at point B, that will decide about the effect of load. So for that, what we do, we apply equal and opposite force at point B. So it means we are adding one system of forces such that the resultant is zero. There is no resultant force, no resultant moment at point B. So whenever we apply such system of forces at any point or any body or any member, it won't make any effect to the system. So that is why we can very safely apply this system of force with equal and opposite forces at the same point. Now what happened? This force and this force constitute a couple, and this value of this couple is nothing but F into E, and the direction of this couple is anti-clockwise because this is direction of this couple is clockwise. So resultant system of force will be F and this moment M, that is this couple M F into E. So if we consider that this is XY plane then this moment will also act in xy plane or along our z-axis. So it means that whenever we have some force, eccentric force, if we want to find out the effect of that eccentric force at some point, it will be replaced with the force as it is and a couple that is given by the magnitude of the force and the perpendicular distance between these 2 points. So now I suppose we can make use of this particular concept to identify the effect on different members. So let us first take this example to identify the effect of this force F which is acting at this end, and if we are interested in evaluating or identifying what is the effect of this force F at this point on the same member. So for this particular point, this force is axial force, and this will induce axial deformation at this point. But if we talk about the effect at some point on this particular member, then we have to shift this force F from here to here, the point where we are interested in identifying the effect. So if I shift this force F here, then it will induce this F into, for example, if this length is L, then F into L would be the moment that is acting in this particular direction, this force, and this force will constitute a couple, and this couple is acting in xz plane like this. So when this moment is acting in a plane which is perpendicular to the plane of cross section of a member, it will induce a bending moment. So now when we see the effect of this force at this point, it is the bending. Now let us see what is the effect of this force on this member. If we consider as such, first let us say point this, then again what we have to do, we have to apply equal and opposite force to see the effect, and this force and this force will constitute a couple. Again, if this is x, this is y, this is z, so this couple will be in xz plane, but the direction this time is like this, the direction of couple, and the moment the bending will also take place in xz plane. The other thing is this whatever is left is this force, which is, you can say, is the transverse shear force for this particular member. Now if we see the effect on this member, what we have to do, we have to transfer this force again. So we can transfer this force like this because first we have shifted from here to here, now we can shift from here to here. This is the moment that is acting in xz plane, so the moment is distance independent, so same moment will be acting here, that is force into let us take this length as E, length of this lever, then F into E is the moment, and this force, because it is along the same direction, we can shift this any force along the line of action of the force without changing the effect, and this is principle of force transmissibility, means we can shift the force along the line of action of the force without changing the effect, and that is why the effect will remain same. But here it means this particular member will be under compressive load, and the effect is compression, and the second effect is the bending in xy plane. Now let us take the third case where load F is acting in along z axis. So again, if we want to find out the effect of this load on two different points, one on the lever, another on the member, we can see this load is transferred with this concept. This load and this load again will constitute a couple, but this time couple is in YZ plane. So the plane of cross section of this member is also YZ, and this moment which is we have shifted here, this is also in YZ axis, in YZ plane. So that is why this will induce a twisting moment. Whenever a moment is acting in the plane of cross section, then it will induce twisting, and whenever a moment is acting in the plane which is perpendicular to the plane of cross section, then it is bending. There can be bending in two planes because one plane is in plane of cross section and there are other two planes which will be the bending plane. Depending on in which plane moment is acting, there can be bending in both the plane. That depends on the load and the effect of the load. So that is how we can identify the effect of load, which is very crucial in identifying the nature of the stress, and then in turn to identify which formula expression we have to use for the stress. So here when the effect is bending, it is bending stresses will be induced. When effect is twisting, it is torsional stresses will be used. So we have the summary of the effect of load here. The member, if the member effect of load is to elongate a member, then the tensile stresses will be induced. We will be using sigma is equal to F by A expression. When the effect of load is to compress a member, and compressive stresses or crushing or bearing stresses will be used, then the formula is this. In case of bearing stresses, sometimes we may have to use projected area. We have a separate video on projected area and bearing pressure that will clear your doubt about when to use projected area and when to use bearing pressure and so on. If the effect of load is to bend a member, then it is the bending stress, both compressive and tensile, and we have to use bending equation. When it is to twist a member, we have to use torsion. This torsional stresses, shear stresses will be developed, and we have to use torsion formula. And if the if the effect is to slide a material layer, then in plane shear stresses will be used or transverse shear stresses will be used. In that case, we have to use this formula or the formula which is of transverse shear stresses, though this will be the average transverse shear stress and we can find out the maximum transverse shear stress, but the magnitude of transverse shear stress is very low as compared to the other stresses. So that is why generally in design the transverse shear stresses are neglected, because transverse load also induces bending and the bending stresses are much larger than in magnitude with as compared to the transverse shear stress. So now let us take an example to understand the effect of load. I will be going very quickly. Let us say this one particular member of a complex shape is fixed with this frame and number of loads are attached with this, and we have to find out what is the effect of the load at this point A. The same problem we'll be doing when we'll be talking about the stresses, and finally we can get how much is the stress at point A. So we will be first considering this force 400 Newton force. So when we transfer this force from B to from D to B, we get this is 400 kilonewton, 400 kilonewton like this and this. It means this load and this load will induce a couple in which will induce bending in XY planes. That value is 400 multiplied by 8 meter. So that is why it is 400 into 8 meter, and this is anti-clockwise moment. So we have the force along x-axis. This is the force along x-axis and this. Now step 2, we have to transfer this load from this system of forces from this point to point this. So the couple doesn't is not distance dependent, so same couple will be transferred here, 400 Newton into 8 meter. And then this force of 400 Newton, when we shift it here, it will be shifted with the another couple that is in xz plane, and the direction is like this. So we have now the final net force is 400 Newton in along x-axis, then 400 into 8 Newton meter, that is 3200 Newton meter anti-clockwise as shown, and another is 400 into 20 400 Newton into 20 meter, that is 8000 Newton meter anti-clockwise. So this is how we can find the effect of 400 Newton force. Now let us consider this 500 Newton force. Again we will be going in the same way. First we will be transferring from point D to C, then C to B, then B to A, and directly we can transfer from 500 from D point to B point. It is our choice, but we should be having one particular plane for transferring. So here when we transfer 500 Newton from from point D to B, we are in XY plane. When we transferred 400 Newton from directly from D to B, we were in XY plane. So if we are in the same plane, certainly we can go to any point, but we cannot directly go from D point to A point A, because in that it is not in a standard plane, it is an oblique plane. Then the calculations are slightly more difficult. Doesn't mean that we cannot transfer this and directly from point D to point A, but in that case we have to identify the angle of the plane, and then the moments are to be resolved, and then this would be the plane in that case, and we have to resolve the moment will act in this particular plane. We have to resolve in the different planes to identify the exact behavior of that moment. So that is why it is always better or simple to go to move in one plane, either xy, yz or zx, and then the point may be different. So we can directly go from point D, 500 Newton, from point D to point B directly, or point D to point C, and then point C to point B. And when we move from point B to point A, we are moving in xz plane, means in same plane we are moving. So that is how we select how to move from from one point to another point and to finally reach with the desired point. So net effect is 500 Newton, directly 500 Newton is this. Then one couple in XY plane. So XY plane couple is 500 multiplied by 10 meter, and this is in YZ plane, that is 500 multiplied by 20 meter. So this is how we can find out the effect of 500 Newton load, that you can try on your own to get the final answer. And we have the net effect of all the forces directly shown here. It is left to you to identify, to go through all steps for each and every load to finally come at point A. And now let us see what is the effect of these forces and moment at point A. So force along x-axis is the transverse load and cause in plane or transverse shear as we discussed. It means it is along this, so it will induce in plane or transverse shear. But this in general we neglect when we talk about the stresses. When we talk about stresses, we neglect this because the value of this stress is very less. So force along y-axis will also induce transverse shear stress. Flow force along z-axis is the axial load and cause elongation if it is acting along the positive z-axis, which is actually this value is along the positive z, so it will induce elongation. The couple MXY is the plane of cross section of this member, where this point A is located. A is located on this member, and the plane of cross section of this member is is in XY plane. So that is why a couple which is inducing, which is acting in the plane of cross section, will induce twisting, and that is why it will induce shear stresses. And the couple in plane perpendicular to the plane of cross section will induce bending in YZ plane, and this will induce bending in XZ plane. Means this will bend like this and this will bend like this. So this bending is in XZ plane and this bending is in YZ plane. So that is how we can identify the effect of load, and that will give us the very clear concept of which equation we have to use for a member to be designed, and to identify the maximum induced stress for applying on the left hand side of the design equation. So that is all for today's session. So thank you. Please subscribe, like and share if you like this video. Thank you.